Welcome to my channel. I want to start a series of maths classes actually. Well, I'm starting with the 10th class maths. Okay, so I'm taking the Telangana Class 10th book and I'll start from the important chapters. I'll try to cover all the chapters, but I'll start with the important chapters which are useful for IOKM also. So, along with the 10th class uh, Telangana 10th class book, first I will finish that and then look at the ICSE books actually and cover the same chapters except for this polynomials, which one I'm starting now right now because the polynomials is most important chapter for the IOQM. Okay, so polynomials ICSE 10th class book don't have a special chapter. It's all part of quadratic equations. So I'll cover that in quadratic equations, but the format of these lessons is like this. So I'll take the 10th class Telangana maths book, uh, take the classes, theory and exercises I will do, and then add ICSE exercises as well as extra anything extra in that. I will add those things and then go for a more rigorous of the same chapter for IOKM and engineering entrance exams. Okay, so this is how we'll start. Okay, okay, let's start. So in Telangana class 10th maths, polynomials is chapter 3. Okay. This 10th chapter is actually a quadratic equation, so I don't cover in this, but I will cover after the Telangana class. I'll cover IOKM and more basically for the polynomials. So this is all for the polynomials. Okay. So first thing is let's try to understand the basic definition of polynomials. If you have a simple question like you have a rectangular dining hall and its length is twice its breadth. Okay, so that means if breadth is x, then length is 2x basically, right? Okay, if length is x, breadth is x, then length is 2x. Now, how do you represent the perimeter as well as area in terms of these variables? Okay, so we call area is length into breadth, which is uh, 2x square, 2x into x, that is 2x square. So 2x square is a polynomial of degree 2. So because the power is 2 here, so it's a degree 2 polynomial. Okay. So this is the basic usage of polynomials, but they can be used in many places. Because this is a very basic, after number theory, this is one of the most basic thing in mathematics, which everybody should know. And most of the problems from IOQM and entrance exams everywhere, all that depends on how much knowledge you have in polynomials. Okay. So polynomial in X is an algebraic expression containing the sum of finite number of terms. So you will have finite number of terms, okay, in the form of a into x to the power of n for a real number a. Okay, a should be a real number and not equal to 0, and n should be whole number. Okay, this is the most important definition. Okay, n should be a whole number. Okay, examples here. 2x is a polynomial of degree 1. 1 by 3 is a real number, so it's still fine because x power 1 is a natural number, whole number, right? So it's fine. 2x square minus 2x minus 1 is a polynomial. But you see what are not polynomials? You have x to the power of 1 by 2. Okay, so if it is not whole number, it's not a polynomial. And you have x to the power of minus 1, that is 1 by x. So it's not a polynomial. 1 by x here, it's not a polynomial. Okay. So hope you understand the basic definition of polynomials. Okay. So just exercise from the book. You know, 2x cube is a polynomial, 1 by x, so not a polynomial. Okay, this is a polynomial. Okay, m square minus square root of 2 only. Okay, m is not under square root, so it's a polynomial. P to the power of minus 2. Okay, so this is 1 by p square, which is not a polynomial. Okay, next. Okay, if px is a polynomial in x, the highest power of x in p of x is called degree of the polynomial. Okay. That is 3x plus 5 if you take the highest power of x is 1 here. Okay, so this is a polynomial of degree 1. It's called linear polynomial. Okay. Now, if you see other examples of linear polynomial, 5x, root 2y plus 5, 1 by 3p, m plus 1, all these are some examples. Okay. Everywhere you see the variable power is always whole number. That is 1. For linear polynomial, it has to be 1 max. Okay. The polynomial of degree 2 is called quadratic polynomial. Okay. Example is 2x square plus 3x minus half p square minus 1. Okay. You may or may not have x term in this. X. Okay. The highest power is always 2. After that, you may or may not have other terms. Okay. So these are the examples. Now, polynomial in the of order, I mean power 3 is called a degree, basically degree 3 is called cubic polynomial. Okay. So 5x cube minus 4x square plus x minus 1 is a cubic polynomial. Okay. Okay. More examples of cubic are given here. Okay. So 6 can be written as 6 into x power 0. Okay. Here x power is 0. So this is polynomial of 0 degree, right? Or constant polynomial. Okay. So these are the types of polynomials based on the degree of polynomial, that is power. Okay. Classification based on degree of polynomial. This is okay. Now the most important definition of polynomial you should remember is this is the basic definition, right? A0 x to the power of n plus a1 x to the power of n minus 1 dash 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 up to an minus 1 x plus an. Okay, this is a polynomial of nth degree. In this one, the rule is okay. The rule is e to the power of 0 cannot be 0. If it is 0, what happens is you don't have a x to the power of nth term. So then the polynomial will become of degree n minus 1. Okay, so this is the must. Okay, and n is a natural number. These are the most important things. Okay. Okay. Now again, types of polynomials we'll learn based on the number of terms in it. Okay. Monomial. In a monomial polynomial, we have only one term. Okay. That is example 2x 4y by 7. Example. Okay. Binomial, you have two terms. Okay. 2x plus 7 square root of p square minus 6 by 5. Right. Trinomial, you have three terms. Okay. Like this. 3x squared plus 5x minus 7. Okay. So this is the classification based on number of terms. Okay. Monomial, binomial, and trinomial. These are all mostly may come in like 10th class objective type questions. So just to have the terminology, I mean, put it in your mind actually. So okay. So the question here is asking same thing. What is the conditions on b0 to bn? Okay, if q of z, that is a polynomial, is like this. So we learnt it b0 should not be 0 basically. That is the main condition, and every bi should become a real number. Okay, it cannot be imaginary. No square root of i's, no i's basically, no square root of minus 1. Okay, and also the power n should be a whole number. Okay, so he is asking about conditions on b0 to bn. So the condition is b0 should not be 0. That's the main, and the bi should be real number. So that's the two conditions basically. Next. Okay, value of polynomials. This is simple. If you have a function p of x equal to x square minus 2x minus 3, uh, at any given value of x, you can evaluate the polynomial value. Okay, suppose at x equal to 1, how do you evaluate? You just replace x equal to 1 in the polynomial. Okay, so p of 1 equal to 1 square minus 2x is 2 into 1 minus 3, that is minus 4. Okay, so p of 1 equal to minus 4, that is polynomial at x equal to 1. Right, so we represent this as p of 1, p of 2, p of 3, like that. Okay, so If p of x is a polynomial in x and k is a real number, then value obtained by substituting x equal to k in px is called value of px at x equal to k, and it denoted by p of k. That's the definition, right? So this is examples. Suppose they gave a polynomial x square minus 5x minus 6. Find out the value of p of 1, p of 2, p of 3, and so on. So I'll just take one of them. Let's take p of 3. Okay, p of 3 equal to x square, that is 3 square, minus 5x, so minus 5 into 3, minus 6, that is minus 12. So this is how you have to evaluate a polynomial for the x values. Okay, and you observe that at some values, this polynomial is becoming 0, correct? So note down this. Okay, we'll come to this point. Okay, next. Okay. So if p of m equal to m square minus 3m plus 1, then find out the values of p of 1 and p of minus 1. So just replace into the m value, and then you will get the values. That is minus 1 and 5. Okay, minus 1 and 5 will get. Next. So just before I was telling, observe that for some of the values of x, the polynomial is becoming 0, right? That is called 0 of polynomial. Okay. The value of the variable for which polynomial becomes 0 is called as the zeros of polynomial. There can be multiple zeros of a given polynomial. Okay. If k is a zero of p of x, which is equal to x plus b, that means p of k, that is equal to ak plus b, is equal to 0. That means k equal to minus b by a. You can evaluate at what value the p of x is going to be 0. Okay. For a simple linear polynomial, this is how we will do. We will also learn for quadratic. Okay. So 0 of the polynomial is ax plus b is minus b by a. Okay. This we understand, right? Next. So it's a simple example here. There is a polynomial given x square minus 4x plus 3. Find the value of p of 0, 1, 2, 3. Okay, we know how to substitute the values, how to evaluate the polynomial. Value of polynomial you can find out. So we find here p of 0, p of 1, p of 2, p of 3. And if you observe p of 1 and p of 3, both are zeros. That means this polynomial, okay, this polynomial has two zeros. That is 3 and 1 are zeros of this polynomial p of x. This is how uh, you will tell. Okay, 3 and 1 are zeros of polynomial p of x. Okay, so observation, for a linear polynomial you have only one zero, correct? That is minus b by a. For a quadratic you got two zeros. Okay, there cannot be two zeros for a linear polynomial, right? It is not possible. Only value is minus b by a. There is no other option, right? But in a quadratic, you have a 0, and you will find out in the coming slides that it can be at most 2. Okay, need not be always 2. There can be 0, there can be no zeros, there can be 1 0, there can be two zeros. Okay, so let's see when it comes. Just observation. Okay. Now, another question can come like this. Check whether minus 3 and 3 are zeros of the polynomial x square minus 9. Okay. So, simple. If you want to find out if given value is 0 of a polynomial or not, just substitute and see. That is as simple as that. So, f of minus 3 is 0, f of 3 is 0. So, minus 3 and 3 are zeros of polynomial. And if you see the polynomial, it is x square minus 9. So if you make this equal to 0, x square minus 9 equal to 0, the values you get for x is, okay, x square equal to 9, x equal to plus 3 and minus 3. So those two are the zeros. Same way how we did for linear polynomial, we just equated this to 0 and then found out the value for k, right? Similarly, exactly same way you can find out for quadratic also, okay, for some of the quadratic equations. Okay, next. So observation, from the observation we can note that maximum number of zeros for a polynomial of degree n is in. Okay, this is the maximum number. You may or may not have uh, a maximum number of zeros for a given polynomial. Suppose if uh, if this is x minus 2 whole square. Okay, x minus 2 whole square has zeros. 2, it is a quadratic equation, so it will have maximum of 2 zeros. And here in x minus 2 whole square equal to 0, both are 2's. So that means you have only one, right? The polynomial has only one 0. So that way, uh, you have to know maximum number of zeros is this much. At most n you will have. Okay. Next. So this is exercise 3.1. All the questions are solved here. Some of them I will tell you. If it is similar, you can. I solved them already. You can go through that. But first thing is any exercise, any example, anything given in mathematics. First you should solve yourself. Okay. The first question is p of x is given. 5 to the 5x power 7 minus 6x power 5 plus 7x minus 7. Find the following. Quotient of x power 5. What is the coefficient? Coefficient is, if you have x power 5 here, the coefficient is the multiplicative value of that term. Okay, that is minus 6. Okay, coefficient of x power 5 is minus 6. Degree of p of x. What is the maximum power in this? 7. So this is the degree. Constant term. This is the constant term which has no x, no variable value, no variable in this. Okay, so minus 6 is the constant term. Okay, so these are the answers. Next, state which of the following statements are true and which are false. That's it. Degree of polynomial square root of 2x square minus 3x plus 1 is square root of 2. No, that is wrong. Degree of polynomial is always power, highest power of the variable. That is 2 here. In this case, x square. So 2 is the degree of the polynomial. So this is false. Okay. Quotient of x in the polynomial p of x. Okay. X term is here 5x. Okay, so quotient is 5, but he's telling the quotient of polynomial is 2, which is wrong. Okay, there is actually none of the terms have quotient 2 in this, right? Okay, so that's also false. Okay, sorry, this is x square. Square is missing here, you can see. Okay, this is x square. The quotient of x square is minus 4. Okay, not x. Next. Degree of constant term is 0. Yeah, that's true. Okay, constant term is always k. If you take like a k x power 0, you call it, right? So 0 is the constant term degree. Okay. Next. 1 by x square minus 5x plus 6 is a quadratic polynomial. Okay. So think, is it correct or wrong? um, as I as we discussed the polynomial definition, here variable term should be always whole number, right? So this is not quadratic for sure because it is 1 by quadratic equation, right? So you will not get x power 2, you may get x power minus 2, something. So this is not a quadratic equation, quadratic polynomial or equation, yeah, of degree 2. Next, the degree of polynomial is one more than number of terms in it. This is absolutely not correct. So these are all basically they will come like a half mark questions in your 10th class exam. So just be careful. No, you know already all these things you understand, but don't go wrong. That's it. You keep doing once in a while, you will never go wrong on this. So degree of polynomial is not number of terms. Degree of polynomial is power of highest variable, highest power of the variable. Okay. If p of t equal to t cube minus 1, find the values of this one. This is just a substitution, so which is very easy. P of 1 equal to, I'm just giving here P of 1 equal to, in place of t, you will replace 1. So 1 cube minus 1, which is 0. So similarly, you will find for other values. Okay. Next. Check whether minus 2 and 2 are zeros of the polynomial x power 4 minus 16. So this is also simple. This you have to substitute and check, right? So f of minus 2 equal to minus 2 whole power 4 minus 16, which is 0. F of 2 is also 2 power 4 minus 6, which is 0. Hence, both are zeros of x power 4 minus 16. Next. Check whether 3 and minus 2 are zeros of polynomial p of x. P of x is given as x square minus x minus 6. Okay. So just substitute, same thing. Yeah, 3 is a 0 because you got the value 0. Minus 2 also is 0 because you got the result as 0. Okay, so both are zeros of p of x. Okay, now geometric meaning of the zeros of polynomial will learn. So if you see the graph here, we can tell this is a line, right? This is a line graph. So that's a linear polynomial, right? Which is intersecting at x-axis minus 2, sorry, around minus 3 by 2 comma 0. This is intersecting at x-axis, y-axis at 0 comma 3. Okay, so this is what you can understand from the graph. Now let's see. Okay, it's a linear polynomial. Y equal to, so we'll write it as y equal to ax plus b, and we calculate for the given values of x. If x equal to some value, two values we'll take, and then for a linear graph, basically linear line, you just need 2 points, right? Then you can construct the line. So you take two values for x, and you will get the values, corresponding values for y, and then you can build a straight line. Okay, example is given here. Y equal to 2x plus 3 is a straight line intersecting y-axis at 0 comma 3, right? Y-axis at, and passes through points minus 2 comma 1 and 2 comma 7. Okay, so you substitute these values, okay, then you will understand. It is going through 0 comma 3. So for x x equal to 0, y is 3, correct. X equal to minus 2, x equal to minus 2, y is minus 4 plus 3, that is minus 1, correct. X equal to 2, y is 7. So these are the points through which this line is passing through, right? Now, important thing to note down is this line y equal to 2x plus 3 intersects x-axis at minus 3 comma 2, minus 3 by 2 comma 0. What is this meaning? Okay, that means at this point the y value is 0. Y value 0 means the polynomial is 0. That means at this x value, the polynomial is 0, which means this x value is the 0 of the polynomial. Minus 3 by 2 is the 0 of the polynomial. This is what it says. And as we know, a linear polynomial will have only one uh, 0. And that is what this, where it is intersecting with uh, x-axis. Suppose if there is a line which is parallel to x-axis, which is never intersects with x-axis, right? Then that polynomial or a linear polynomial don't have a 0. Okay, it is something like y equal to 5. Y equal to 5 will never have a 0, right? Y will never be 0, basically. Okay, okay, at y equal to 0, y is equal to 0 at x equal to minus 3 by 2. So minus 3 by 2 is the 0 of the polynomial. So from the graph, this is what we can understand. So for any polynomial, if you draw a graph, you check how many times it is intersecting with the x-axis, and those are the zeros of the polynomial. For the linear graph, we'll have only one. For quadratic, you may at most have two. Cubic, you may at most have three. Okay. So for a linear, obviously it is minus b by a is the 0 of the polynomial. So if you see here, minus b by a is minus 3 by 2. That's 0. Okay. Next. So quadratic polynomial. So if you see a quadratic equation, and you take any quadratic equation, the graph comes something like this, open well, or sometimes it will be reverse also. Okay, depending on the value of the a. Okay, if this is called parabola. Okay, this graph is called parabola. Okay, uh, general quadratic equation is ax square plus bx plus c. The graph opens up for a is greater than 0. If a is greater than 0, it will be like this, shown. If a is less than 0, it will be reverse. It will looks like a bell. Okay. Quadratic equation has two zeros. This quadratic equation given one, because it is intersecting with the x-axis at 2 points, minus 1 comma 0 as well as 4 comma 0. So at minus 1 and 4, y is equal to 0. That is polynomial value is 0. Okay. So minus 1 and 4 are two zeros of this polynomial. Now look at how this graph is drawn. Okay, for a linear graph, we know that for drawing a line, 2 points are enough, right? But for a bell curve like this or a parabola like this, it's better to take a few points actually. It is very important where it will basically get this point actually. This point is most important where it takes a turn upward. Okay. So here he took x equal to minus 2. Then for that y value is, this is the graph basically, x square minus 3x minus 4 is the graph here drawn. So for x square minus 3x minus 4 at x equal to minus 2 value is 6. So point is minus 2 comma 6. Similarly, he built for minus 1 which is 0. So minus 1 comma 0, 0 comma minus 4, 1 comma minus 6 like this. And then he just plotted this graph. Okay. So again note, again given, a polynomial of degree n will have n zeros at most. Okay, so this should go into your mind. This should be, yeah, you should keep repeating this one. Next. So in the textbook, try this part. He has given a few polynomials, that is x square minus x minus 6, and asked us to draw the graph. So the graph looks like this. So how do you draw this graph? Basically take few points, okay, a few x values, maybe x equal to start from the negative side to positive side, maybe minus 2, minus 1, 0, 1, 2, 3. Then you will get this graph can be plotted. Okay, so this graph has two intersections with the x-axis, that is minus 2 and 3. So these two are the zeros of the polynomial, minus 2 and 3. And this one is, see, here a is minus negative value, right? Minus 1. So the graph is reversed, basically, like a bell. Okay, parabola open downside, downwards, right? So this is how the graph is, and here the zeros are minus 3 and 2. And how do you draw? Same. You take few points and then draw it. Okay. So yeah, we found the zeros of this one. And now graphs can be like this. Okay. This we saw. Two roots both are positive in the first graph. Two roots, one is positive and one is negative. Okay. And this is one root. Example is x minus a whole square. Okay. Then this is also one root. Okay. So one is a minus x whole square, and other one is basically x minus a whole square, like that. Okay. Now these graphs, these parabolas are not touching the x-axis, which means whatever is the equation, one example is given here, x square plus 2x plus 4, it will not have a 0. Okay. There is no 0. Whatever is the value of x you take, you always get more than 0. The y value is always more than 0. So it will never go and touch the x-axis, which means these there are some quadratic equations which don't have zeros. Okay, let's try this. Write three quadratic polynomials that have two zeros each. Okay, very simple. You want two zeros, right? So obviously you take x minus 3 into x minus 2. Okay. If I equate this to 0, basically the zeros are 3 and 2, correct? If I equate this side to 0, x minus 3 equal to 0 and x minus 2 equal to or x minus 2 equal to 0. X minus 3 equal to 0 means x equal to 3, x equal to 2. So I took 2 and 3 as the zeros and then I built a quadratic equation like this x minus 3 and into x minus 2, which is this one. So this is the quadratic equation which will have two zeros, that is 3 and 2. Three equations is it, so you can build other. Okay. Write one quadratic polynomial that has one zero, only one zero. Okay. How you will have one zero? That means both should be repeated. Both terms should be same. If it is x minus 2 into x minus 2, then it will have only one zero, that is 2, right? Or x minus 3 into x minus 3. X plus y plus 5 into y plus 5 or y minus 6 into y minus 6. If it is same, then that's what you get. So basically it's a square, p minus 5 whole square, which is p square minus 10x minus 10p basically. P square minus 10p plus 25. Okay. So this has only one zero. How will you verify a quadratic polynomial has only one zero? Okay. Draw a graph. That is the best way actually. How many times graph is cutting the x-axis? That is one way. And once you know the quadratic equation roots, that way also you can find out it if determinant is zero basically. Um, the quadratic equation polynomial has only one zero basically. Okay. Write three quadratic polynomials that have no zeros. Okay. How do you get no zeros equations? Okay. So best way is you take a completely positive value and yeah, and you cannot basically factorize this. Okay, 2x cannot be uh, from the factors of 4. 2x cannot come from the factors of 4, right? So that way you can write the polynomials which don't have zeros, any zeros. Okay. If you see here, 25 factors are 5 into 5. 10 you can write as minus 5 into minus 5. Correct? Minus 5, which is minus 10, and minus 5 into minus 5 is 25. So if that doesn't, if four don't have factors where you can make two, sum by summing up or subtracting, then that don't have zero. Or once you know the quadratic equation, the determinant should be negative. Okay, b square minus 4ac we call, right? B square minus 4ac should be negative. So that means here if you take this is b, a, b, c, right? B square, that is 2 square minus 4ac, 4 into 1 into 4, 16. So okay, 4 minus 16 is minus 12, which is negative. So determinant is negative, we don't have zeros. Okay. Now just to look at the graph actually. Um, These are the graphs for y equal to x square by 2, y equal to x square, y equal to 2x square. If you see the coefficient is half here, coefficient is 1 here, coefficient is 2. And see how coefficient is half is wider. As coefficient is increasing, the parabola is basically getting closer. The open place of the parabola is getting closer, right? So just observation. Each one is a parabola or bell curve. Each polynomial has only one zero because all are going through zero, right? As coefficient increases, the bell curve is getting narrow on open side. They are symmetric bell curves around x-axis. Okay, so these are the observations which we can make. Next. Plot more graphs for given polynomials and write your observations. Okay, y equal to x square plus 1, that is the red graph here. Okay, and other one is y equal to 2x square plus 1. Okay, as we know, the coefficient increases, it gets narrower, right? So the blue one is basically 2x square plus 1. Okay, each one is parabola. Okay, and then obviously they don't have a zeros actually. For whatever value of x you give, you will never get y equal to 0. So not touching x-axis. Okay, coefficient, as coefficient increases, bell curve getting narrower. Okay, then they are symmetric bell curves around y-axis. Next, geometrical meaning of zeros of a cubic polynomial. Okay, now what is the meaning of this? A cubic polynomial, um, something like x cube minus 4x looks like this. Okay, if you draw on the graph, it comes like this. And if you see, it is cutting the x-axis at three places: minus 2 comma 0, 0 comma 0, and 2 comma 0. Right? At three places, that is minus 2, 0, and 2, the y value is 0. Okay, that means it has three zeros. Right? This polynomial has three zeros. So as we learned that cubic polynomial can have at most three. This has all the three. Okay. How to build it? How to draw this graph? Again, same way. Take some values for x and then calculate the value for y and then plot the graph. Okay. So these are the other cubical polynomial graphs. They look like this. Okay. First one is y equal to x cube. This one. Okay. And this is y equal to x cube minus x square. So it has two zeros basically. And y equal to x cube has only one zero, that is 0. At x equal to 0, y will be 0. That's it. That's the only 0. There is no other 0 possible. Okay. So hope you understood the graphical representation of polynomials from this. Okay. Find the zeros of following cubic polynomial without drawing. Okay. First one, minus x cube. How do you do? Just you have to equate it to 0, right? This is y equal to minus x cube. You have to make y equal to 0. So minus x cube equal to 0. So x equal to 0. That's it. That's the only 0 of the polynomial. X equal to 0. Okay. X square minus x cube. So here you take x square common. So it will become x square into 1 minus x equal to 0. So x has two zeros, either 0 or 1. Okay. This it has two zeros. Third one is x cube minus 5x square plus 6x. First you take the x common. Then it will become x square minus 5x plus 6. And 6 is, we can write it as 2 into 3. So minus 2x minus 3. So this will become x minus 2 into x minus 3. You can factorize basically. So x into x minus 2 into x minus 3 equal to 0, which means x has three values: 0, 2, and 3. These are the three values. So this is how we can find out zeros of a polynomial. You should be good in finding out factors of a polynomial basically. How many zeros of the below graphs? Okay. Take the first one here. There's only one crossing with x-axis. So 1, 1, 0, two zeros here and here. Three zeros, 1, 2, 3, three zeros. This has only 1 0 here, linear. Bell curve, but 1 0. Okay. I don't know what curve is this, but it has 1, 2, 3, 4. Mostly power 4, polynomial of degree 4. So it has four zeros. So this is how from the graphs you can find out how many zeros very easily. We don't need to do calculation of factorizing the polynomial, all that. If you want to just know how many. And from the value also you can find out what is the zero value. Okay. Find the number of zeros of the given polynomial, also find their values. Okay. First one is Very simple. It's a linear polynomial, so obviously it will have at most one zero. So p of x equal to 0, that is 2x plus 1 equal to 0, x equal to minus half. Okay, that's a 0. Second one is quadratic, so it can have at most 2. So let's find out y square minus 1 equal to 0, y square equal to 1. So y can have plus 1 or minus 1. These are the two zeros. Third one is z cube equal to 0. So obviously you have only one value, that is z equal to 0. 0 is, there is one 0 actually, sorry. The 0 is, yeah, 0 is 0, correct. Okay, next. Okay, this is from the exercise chapter. The question is, each case you have to find out number of zeros. We have done this exercise before, so quickly go through this. There is no zeros here. It is not touching x-axis at all. 1 0, 1, 2, 3 zeros, 1, 2 zeros, 1, 2, 3, 4 zeros, 1, 2, 3 zeros. Okay, so you can see all. Okay, so these are the answers. Try the exercise yourself before looking into the solutions here. Next, find the zeros of the given polynomials. P of x equal to 3x, which is very simple. 3x equal to 0, you'll make x equal to 0. That's a 0. X square plus 5x plus 6, which is equal to 0. So you will make 6 is 2 into 3. So 5, you will write it as 5x, 2x plus 3x, and factorize it. You will get x plus 2 into x plus 3 equal to 0, which means x equal to 2 minus 2 or minus 3. These are the zeros. So similarly, you will do for all like this. You can do it yourself and refer this video for the answers, and if you can't do any of them, you can refer this. Next, draw the graphs of the given polynomial and find the zeros. Justify the answer. Okay, fine. So to draw any graph, first thing you need is points. Okay, so x square minus x minus 12, so that is p of x. So I have taken values minus 1, then evaluated minus 1. If you take one of them, I will tell you minus 1 square is 1, minus of minus 1 is 1, so 1 plus 1 2, 2 minus 12, which is minus 10. Okay, so minus 1 comma minus 10. So other value 0 I took, then this is the value, these are the values. With these values you can plot a graph. Okay, the graph comes like this. Okay, if you take all the key values which I got, I plotted, then I found that the bottommost is here basically. And how many zeros it has? Minus 3 comma 0 and 4 comma 0. These are the two zeros. Okay, it has two zeros, minus 3 and 4. And how to justify? You substitute and see. We know quadratic equation can have maximum at most two zeros. If these are the two zeros, then we don't need to search for others, right? So p of minus 3 equal to 0, p of 4 equal to 0. So we verified it. Next. So again, these are all similar questions. Try to solve it yourself. Otherwise, look into the solutions here. Okay. For everything, you need to take points and draw the graph and then find out. Okay. So this is the third graph. Okay. This is the fourth one. Okay. This is the fifth one. Okay. Okay. This is a different question. Check whether minus 1 and 1 by 4 are zeros of the given polynomial. This is simple, right? We already know substitution method, right? P of minus 1 is 6, so it's not a 0. P of 1 by 4 is equal to 0, so it's a 0. Okay, so that's how we'll do. Now, relationship between zeros and coefficients of polynomial. Okay, this is another important thing. Uh, so far you learned is basics of polynomial, but from here real problems will start actually. Okay, if f of x equal to ax plus b, 0 is minus b by a. That is simple. For a quadratic equation, Sum of zeros equal to minus x coefficient by x square coefficient, that is minus b by a. If ax square plus bx plus c has two zeros, then sum of the zeros equal to minus b by a. Product of zeros equal to c by a. Okay. Now you can take any quadratic equation, factorize it, and find zeros, and then check this observation whether it is correct or not. Okay, these relations. This is the most important points to note down. Okay. Okay. So do this. There is one question. This question I'll do. P of x equal to x square minus x minus 6. Minus 6 can be written as minus 3 into 2. Okay. So minus x can be written as minus 3x plus 2x. So that is how we factorize, right? So x square minus 3x plus 2x minus 6, which is equal to x minus 3 into x plus 2. This is what you will get. This you will equate it to 0, correct? So zeros are 3 and minus 2. Now sum of zeros equal to what we learned is minus x coefficient by x square coefficient. Okay. So from here minus x coefficient is minus of minus 1. Minus of minus 1 by x square coefficient, that is 1. So 1. Okay. If you sum these two, 3 minus 2, you will get same 1. Okay. So we verified it. Now product is constant term by x square coefficient. Constant term is minus 6 by 1. Correct? Minus 6 by 1, which is minus 6. This is same as 3 into minus 2, which is minus 6. Okay. So this is how you will verify, you will do. Okay. This is another similar problem. Do it same way. You can try it yourself. Otherwise, refer to the videos. Okay. Third one, same. Only thing is, if you see here, p of x equal to x square minus 4. So I haven't used the same way of factorizing it. We know that a square minus b square equal to a plus b into a minus b, simply. So that's how I used it. So zeros are minus 2 and plus 2. Now you can easily find out. So zeros, sum of zeros equal to minus x coefficient. There is no x coefficient here. So 0, 0, that is 0. And if you sum these two, 2 minus 2, you get 0. So it's verified. Product is minus 2 into 2, which is minus 4. And here also it's minus 4. So it's same. Okay. This is the other one. Similar. Okay. So in general, suppose alpha and beta are the zeros of quadratic polynomial. P of x equal to x square plus bx plus c, where a is not equal to 0. Then x minus alpha and x minus beta are the factors of P of x. Okay. So that is how you actually build this relation. Very easily you can prove it. Okay. So ax square plus bx plus c equal to k into some constant x minus alpha into x minus beta. That is k into x square minus alpha plus beta into x plus alpha beta. Okay. So yeah, k, you take the k inside each term. Now you uh, see actually a equal to k, b equal to minus k into alpha plus beta, c equal to k alpha beta. Now given that alpha plus beta, sum of zeros is minus b by a. So you can easily see that, correct? Okay. And alpha beta equal to, that is product of zeros is c by a, right? Because k is a, so you can replace c by a. Okay. Find the quadratic polynomial whose sum and products of zeros are minus 3 and 2 respectively. So this is very easy. Just now we learned if minus 3 and 2 are the zeros of polynomial, then x plus 3 and x minus 2 are factors of that polynomial. Okay. Oh, sorry. It's given Sum and product of zeros are minus 3 and 2. So that means alpha plus beta equal to minus 3. Okay, and alpha beta equal to 2. Okay, that is C by A. Okay, from this we can easily compare A equal to 1, B equal to 3 and C equal to 2. That way you can construct it x square plus 3x plus 2, or we can keep some constant k. Then also that's the equation. Okay, this is the polynomial. This is how you should construct, because it is sum and product are given here. Okay, next, find a quadratic polynomial with zeros. This is with zeros. Okay, alpha equal to minus 2, beta equal to 1 by 3. So it is as simple as x square minus 2 plus 1 by 3 x minus 2 into 1 by 3. That's how you will build it. So you will get 3x square plus 5x minus 2. Okay, here again sum of zeros is given and product of zeros is given. So we know that if sum of zeros is sum of zeros, we will replace here with x. Actually x is there here. Product of zeros is minus 1, so minus 1 you replace here. So x square minus 3 by 2x plus minus 1. Okay, so the polynomial is this one. If you don't want to keep fractions in the coefficients, you just multiply the polynomial with the denominator. So now let's learn the cubic polynomial. Now let's look at the cubic polynomials, and let's find out the relation of those coefficients and the zeros. Okay. So do you think the same kind of relationship holds on the coefficients and the zeros? Let's try to find out. So p of x of a cubic polynomial is something like ax cube plus bx square plus cx plus d. Okay. Let's say this has the zeros, alpha, beta, and gamma. Okay. Now we know that if alpha, beta, gamma are zeros, then polynomial can be written as x minus alpha into x minus beta into x minus gamma. Right. So that is nothing but if you simplify into the x cube, x square, x terms and constant term, looks like something like this. X cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus alpha gamma alpha into x minus alpha beta gamma. Okay. So if we multiply the each term with the constant, the same constant, that is a, then it looks something like this. Okay. Because we don't want to keep the x cube coefficient as 1. It can be anything in a given cubical polynomial. Now let's compare the uh, coefficients and the zeros relation. So alpha plus beta plus gamma is very clearly is nothing but minus b by a. Correct? Correct. So because if you take b equal to minus a into alpha plus beta plus gamma, okay, c equal to this, d equal to this, right? So alpha plus beta plus gamma is minus b by a, alpha beta plus beta alpha plus uh, beta gamma plus gamma alpha equal to c by a, alpha beta gamma is minus d by a. Okay, so these are the relations between the coefficients and the zeros. Now let's try this. If ABC are the zeros of the given cubical polynomial, find the values of the expressions given in the table. So what you need to find out is those three uh, zero relations basically. Sum of zeros, uh, product of two zeros summation plus product of zeros. Okay. So if it is x cube plus 3x square minus x minus 2. So we know that it is minus 3 minus b by a. So it is minus 3 by 1, that is minus 3. A plus b plus c. Now ab plus bc plus ca is nothing but minus 1 by 1, that is minus 1. ABC is minus of minus 2 by 1, which is 2. Okay. So same way you can do for other terms. Okay. Now let's go to the exercise 3.3. Okay, find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients. Okay, x square minus 2x minus 8. Okay, we can factorize minus 8 can be written as minus 4 into 2 and minus 4 plus 2 equal to minus 2. So we can factorize it and find out the zeros. The zeros are the factors are basically x minus 4 into x plus 2 equal to 0, which means zeros are x equal to 4 and minus 2. Okay, so zeros of the given polynomial are 4 and minus 2. Now sum of zeros is 4 minus 2, which is equal to 2, right? 4 minus 2, so sum is 4 minus 2, which is 2. And from the given polynomial, minus b by a, that is minus of minus 2 by 1, which is 2, right? So this is verified. Similarly, product of zeros, okay, is 4 into minus 2, which is minus 8. And from the polynomial, it is c by a, that is minus 8 by 1, which is minus 8. So verified. So similarly, you have to do for other problems given actually. And yeah, just try it yourself. They are simple and you just follow the template here. Uh, yeah, same thing here. Okay, same thing here. And here, when you are factorizing, just be careful. You don't have a constant term, so you can just take u as common, that is 4u as common, then u plus 2. So u equal to 0 or minus 2. These are the zeros. Okay, and rest of the work you will do same way. Okay, here also t square minus 15, you will write it as a square minus b square, that is a plus b into a minus b of square root of 15. So roots are plus or minus square root of 15. Okay, so all are similar. Now, yeah, problem 2. Find the quadratic polynomial in each case with the given numbers as the sum and product of its zeros. Okay, sum and product are given. We need to find out. This is 1 by 4 is the sum of zeros and minus 1 is product of zeros. Let's see how to do. Alpha beta are zeros of polynomial given that alpha plus beta equal to 1 by 4, alpha beta equal to minus 1. So polynomial is basically x square minus alpha plus beta x plus alpha beta, right? So it will become x square minus 1 by 4 x plus of minus 1. So that is nothing but x square minus 1 by 4 x minus 1. So if you don't want the denominator, you multiply all the terms with the 4, then 4x square minus x minus 4. Okay, this is the answer. So similarly, you can do the next one. Sum of zeros is square root of 2. Product of zeros is 1 by 3. Okay, same way you will do. Just try it yourself. Okay, next. Yeah, this is again same question. So you'll find 0 is sum of zeros. That is alpha plus beta is 0. Alpha beta equal to square root of 5. So you will do it in the same way. Last one is 1 comma 1. So here if you see clearly it is same root. So alpha plus beta is 1 and alpha beta equal to 1. Okay, sum and product is same. Now you substitute, what you will get is x square minus x plus 1. This is the answer. Okay, find the quadratic polynomial in which in each case with the given numbers as the sum and product of its zeros, which is same. Okay, so minus 1 by 4 and 1 by 4, alpha plus beta is minus 1 by 4, alpha beta is 1 by 4. So you will do again same way. Template is already there, 4 comma 1 same. Okay, go. Yeah, find the quadratic polynomial for zeros, alpha, beta given in each case. Okay, in this one, zeros are given. Now you need to find. Uh, okay, so alpha is 2, beta equal to minus 1. So alpha plus beta equal to 1, alpha beta equal to minus 2. Rest of the work is same as before. We'll substitute alpha plus beta here, alpha beta here value. Then you will get the polynomial. If there is a denominator, multiply it with the all the terms with the denominator so that you will not have a denominator. Okay. So this second one also same way you will do. Yeah, third one, same. First find out alpha plus beta and then, or other simple way is basically x minus alpha into x minus beta. You can do it yourself. That's also fine. but you need to do multiplication of polynomial at that time. Verify that 1, -1 and +3 are zeros of the cubic polynomial given here, and check the relationship between zeros and the coefficients. Okay, yeah, this looks simple. How do you verify normally? Substitute and see. So f of 1, f of -1, f of 3. These three values will find out. So f of 1 is 0. Okay, hence it is a 0 of f of x. F of -1 also 0. F of 3 also 0. Okay, so all three are zeros of the polynomial. How do we verify? We know already alpha plus beta plus gamma equal to minus b by a. So in this case, okay, minus b by a is nothing but minus of -3 by 1, that is 3. Then alpha beta plus beta gamma plus gamma alpha equal to, yeah, given is -1 -3 plus 3, that is -1, and which is c by a, that is same, -1, verified. So same way alpha beta gamma also you can verify, -3 and -3. Okay, next. Now let us understand the division algorithm for the polynomials. This is a very important topic for the polynomial. Okay, so a cubic polynomial has at most 3 zeros that we know. Okay, however, if you are given only one zero, can you find the other two? Is it possible? Okay, so that's the question. Okay, if one zero of x cube plus 3x square minus x minus 3, okay, one is a zero of this cubic polynomial, then what are the others? Okay, so if 1 is a 0, then x minus 1 is a factor of this polynomial. So we have to divide the given polynomial p of x with x minus 1. Okay, let's say x minus 1 is g of x, then you have to divide p of x with g of x. Okay, so how do we do that? We have a long division method actually. Okay, similar to the long division of numbers we do. Okay, same way we will do it here. So you write the polynomial here, p of x and g of x here. Okay, then x, now we know that we have to multiply whatever term we are going to get here, we have to multiply that with both these terms, right? X and minus 1. So first thing is, you observe this is x cube here. So what is that you need? We have x here. So what we need is x cube by x, that is x square is what is required. So you take x square here. Okay, so it will become x cube and minus 1 into x square, that is minus x square. So two terms you will get, right? So write the two terms here, and then same way you subtract it. What you will get is 3x square plus x, uh, 3x square plus x square, that is 4x square. And then bring the minus x down, that is minus x here. Now you check x and 4x square here. So what we need is plus 4x. You have to multiply x with plus 4x to remove this, right? So plus 4x. Now what you will get is 4x square minus 4x. If you subtract it, what you will get is 3x minus 3. Correct? 3x minus 3. Now 3x by x is 3. So plus 3. So what you will get is 3x, and minus 1 into 3 is minus 3. This if you subtract, you will get 0. Right? So this means the polynomial p of x, that is x cube plus 3x square minus x minus 3, equal to x minus 1 into x square plus 4x plus 3. Okay, how? If you see here, the quotient is x square plus 4x plus 3. Okay, so this is another factor, right? Because remainder is 0. Okay, so we can rewrite this as this way. And obviously, we can easily simplify x square plus 4x plus 3. Okay, so that is factorizing, you will get x plus 3 into x plus 1. So given polynomial is x minus 1 into x plus 3 into x minus 1. So zeros are 1, minus 1 and minus 3. These are the three zeros. Okay, so this is a long division algorithm for the polynomial. So just examples, you can go through the examples. Here it is given 2x square plus 3x plus 1 divided by x plus 2. So you write x plus 2 here, and the given polynomial here. 2x square by x is 2x. So first you will take 2x as a term. So x into 2x, that is 2x square. 2 into 2 into 2x is 4x plus 4x. If you subtract, what you will get is minus x, then plus 1 you bring it down. Okay. So x into minus 1 is minus x. Okay. 2 into minus 1 is minus 2. So what you will get is remainder 3. Now we have to stop because there is no other term we will get from here which will give you 3. Okay. So in this case, if you see clearly, 2x square plus 3x plus 1 is dividend, correct? Equal to divisor, that is x plus 2 into quotient, okay, that is 2x minus 1 plus remainder. This just like any number theory, right? Division of the long division of the number theory. Same way you can write it. Okay. So this is called division algorithm. What is it? P of x and g of x are any two polynomials where g of x is not equal to 0. Then we can find polynomials q of x and r of x, r of x, rx, or in such a way that p of x equal to g of x into q of x quotient, okay, plus remainder, that is rx. Okay. If rx equal to 0 or degree of rx is less than g of x, this is where we stop basically, right? This result is known as division algorithm for the polynomials. Okay. If gx is a linear polynomial, then r of x equal to r, you will get a constant basically. Okay. So these are the observations which you can make. Okay. Next. Again, there is another example given here in the book. Okay. Divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square. You write it in the proper order first. Minus x cube plus 3x square minus 3x plus 5 with x square minus x square plus x minus 1. So here three terms are there. So at any time you will get three terms here, right? So first one is minus x cube minus x square, that is x. If you take x here, minus x cube, x into x square, minus 1 into x minus x. So if you subtract, what you will get is 2x square minus 2x, then plus 5 you will bring it down. Okay, then minus 2 you will get a remainder as 3. Okay, so this is dividend equal to divisor into quotient plus remainder if you write it like this. Okay, next. So another example here. So you can go through the example, they are all simple. Okay. So here they are telling that find all the remaining zeros of 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. If you know the two of its zeros are square root of 2 and minus square root of 2. Okay. So in this case, we know that we need to make one polynomial, that is g of x, you have to make one, right? How do you make? It is given that square root of 2 and minus square root of 2 are zeros, which means x minus square root of 2 and x plus square root of 2 are factors. Multiply them, what you will get is x square minus 2. This is g of x. So you divide the given polynomial with x square minus 2. There is a 0x here. Okay. Just for convenience, it is easy to put, so keep it. Then divide it, what you will get is 2x square minus 3x plus 1 as the quotient, and the remainder is 0. Okay. This is how you decide the first term of, the terms in the quotient. You take the first term with what you want to divide and then divide with the first term in the g of x, then you will get what should go to the first term of quotient. Okay. Next. So this is the continuity of the previous problem. This is the quotient you got. Then you factorize it again. Then what you will get is 2x minus 1 into x minus 1. So the zeros are square root of 2 minus square root of 2, 1 and 1 by 2. Okay, now this is exercise 3.4. Let's solve this. Divide the polynomial p of x by the polynomial g of x and find the quotient and the remainder in the following. Okay. So first problem is p of x equal to x cube minus 3x square plus 5x minus 3. G of x is x square minus 2. Okay. So if you divide, this is what you will get basically. Okay. Quotient will be x minus 3 and the remainder is 7x minus 9. We have to stop here because the power here is x square. So you can't get 7x from here. Okay, you can't give 1 by x, right? So you have to stop it there. Okay, so quotient is x minus 3, remainder is 7x minus 9. Okay, just make sure that you put the positive, negative properly so that you don't go wrong. In case you think whether the answer is correct or not, you do the reverse calculation. You multiply quotient and g of x into q of x, and then add r of x to it. You should get the p of x value, right? Next. Next also same. You have x power 4 term here and x square minus x plus 1 as um, dividend. And the p of x is here, g of x is here. So if you do step by step, what you will get quotient is x square plus x minus 3. Please go through this division properly. Okay, now quotient is x square plus x minus 3. Remainder is 8. Okay, next. Okay, yeah, similar. X power 4, and there are two terms missing, x cube and x square terms are missing. So you just put them 0 for convenience, and it is easy to do because you get, since there is a minus x square is there, you for to get x power 4 you need minus x square, so you will get x square term, so you better put 10 x square term here. Okay, missing one. So with this what you will get is quotient is minus x square minus 2 and remainder is minus 5x plus 10. Next. So they gave all the problems different types actually, where you will basically face different small challenges there for the long division. So do it carefully. You have to solve all these problems, not just watching it. So only then you will become perfect. Okay. So this one also, it's a straightforward method. Only thing is, if you see t square minus 3 is there, the t term is missing. Okay. So carefully do it. So with this, what you will get is remainder is 0. Okay. So t square minus 3 is the factor of given polynomial. We have to uh, check here in this case if this is a factor or not. It's a factor because remainder we got is 0. Okay. So second question, second problem. We have to check if x square plus 3x plus 1 is a factor of this polynomial p of x. Okay. So do long division again. We got remainder 0. Okay. You continue this step by step and then you will get remainder 0. So it's a factor, right? It's a 0. So x square plus 3x plus 1 is a factor of given polynomial. Okay. Same second problem. You have to check x cube minus 3x plus 1 as a, if it is a factor of this given polynomial. So if you do the long division here, you get 2 remainder, which means it is not a factor. Oh, sorry, I just copied it from the previous one. This is wrong. Okay. So, so this is wrong. It's not a factor. Okay, it's not a factor. Okay, next. Obtain all zeros of polynomial if two of its zeros are given. Okay, so we know how to do it. If two of its zeros are given, which means x minus square root of 5 by 3 and x plus square root of 5 by 3 are factors of the given polynomial. You multiply them, what you will get is x square minus 5 by 3. This is a factor. So now you do a long division. Okay. So if you do the long division, x square minus 5 by 3 and polynomial is here. Okay. So what you will get is 3x square plus 6x plus 3 and the remainder is 0. So 3x square plus 6x plus 3 is another factor. Now you can factorize it, basically x plus 1 into 3x plus 3. Okay. 3x plus 3 is nothing but x plus 1. So basically you have only x plus 1 as x plus 1 whole square as other factor, which means other 0 is only x equal to minus 1. This is the only other 0. Even though it is x to the power of 4, you have only 3 zeros for this one. Next, do the long division carefully. These all whole exercise is for long division mainly. Okay. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, quotient and remainder are given. Quotient is x minus 2 and the remainder is minus 2x plus 4 respectively. Find g of x. We know we can do it reverse. So take the p of x. You need to find g of x, q of x and r of x are given. So what you follow is basically p of x equal to g of x plus into q of x plus r of x. Okay. So g of x is nothing but p of x minus remainder divided by quotient. Okay. So if you subtract, what you will get is x cube minus 3x square plus 3x minus 2. So you do a long division with x minus 2, which is the q of x. So it should divide basically. Okay. So it divided and you got 0 answer there. So g of x is nothing but x square minus x plus. Okay. So this is how these such problems should be done. You just remember this main equation. This is same in number theory also, right? P of x equal to g of x into q of x plus r of x. That's it. Next. Give examples of polynomials which satisfy the division algorithm. Okay. And 1. Degree of P of x equal to q of x. First one is okay. So is it possible? First thing, degree of g of x, p of x and q of x should be same. Is it possible? Yeah, it is possible. In that case, g of x is a constant term basically. Okay. Now next is um, second one is degree of q of x equal to degree of r of x. Okay. Is it possible? Okay. P of x equal to x cube plus x and g of x equal to x square. So degree of now q of x, what you will get is basically if you divide x, correct? You get x. Okay. So if q of x is x and r of x also, you'll get x. So in that case, you have same degree. Now degree of r of x equal to 0, there are so many. You can get r of x equal to 0. That means remainder is 0 basically. So many examples you can get. One is given here. Next. So this is the optional exercise which is given there. But there are some good set of problems here. So let's see. Verify the numbers given alongside the cubic polynomials below. Are there zeros or not? Okay. Also verify relationship between the zeros and the coefficients in each case. So we have done this before. We just need to redo once. So verifying is very easy. If a given number is a 0 of the polynomial or not, you just substitute, right, for the x value. So f of 1 by 2, f of 1, f of minus 2, you will find out. Okay, 0, 0 and 0. So they are zeros of the polynomial. And relationship we know already from this. So we can easily tell what is the relationship. You can verify also. Okay, we have done this problem before, so follow the same template. Next, find a cubic polynomial with sum of products of its zeros taken 2 at a time and the product of its zeros as 2, minus 7, minus 14 respectively. So what they are trying to tell? Trying to tell alpha plus beta plus gamma is 2, alpha beta plus beta gamma plus gamma alpha equal to minus 7, alpha beta gamma equal to minus 14. So this is the quadratic equation, right? This is how you will write. This is the polynomial. Okay. If the next question, third, if the zeros of the polynomial given are a minus b, a and a plus b, find a and a and b. Okay. Yeah, this is simple. We know the relationship between the zeros. Okay. So sum of zeros is a minus b plus a plus b, which is equal to minus of minus 3 by 1, okay, that is alpha plus beta plus gamma is minus b by a, right? So you will get that as 3. So 3a equal to 3, that means a equal to 1. Now you got a equal to 1. Now product of zeros is a minus b into a plus b, and a is already 1, we know. So 1 minus b into 1 plus b, which is equal to minus 1. Okay, that is minus d by a, correct? Which is minus 1 here. Okay, so minus 1. Now 1 minus b square equal to minus 1. Okay, so which means b square equal to plus or minus square root of 2. B is basically. Okay, so now you got b also. Now next question. If two zeros of the polynomial are 2 plus or minus square root of 3, find the other zeros. Okay, so this is again simple. First they are given two zeros, so you make factorize them and then we do long division, right? Okay, so x minus 2 plus square root of 3 and x minus 2 minus square root of 3 are two factors. Okay, it divides this polynomial. Okay, so long division is given here, x square minus 4 minus 4x plus 1. If you divide, what you will get is x square minus 2x minus 35. This is what you will get. Okay, x square minus 2x minus 35. This is the other factor. Now, if you factorize it, what you will get is you can write minus 35 as minus 7 plus 5, correct? Minus 7 into 5 and minus 7x plus 5x. So from this, if you factors, what you will get is x minus 7 and x plus 5. These are the other two factors. So x equal to 7 and minus 5, other two zeros. Okay. So this is how we should do. We have done this before. So we'll follow the same steps here. If polynomial is divides another polynomial, okay, x square minus 2x plus k, the remainder comes out to be x plus a, find k and a. Okay. So this is what p of x is given, g of x is given. In the g of x you have minus k. Okay, so this is important, and r of x has another constant a, x plus a. Okay, so just do a long division. Okay, carefully write the k terms and a terms. Okay, a term won't come now, but the k terms will come actually. So finally you will stop when you will stop when in the remainder your x to the power degree of x is less than uh, degree of x in the uh, uh, divisor, right? So at that point you stop it. So we stopped it here. Minus 9 plus 2k into x plus 10 minus 8k plus k square. This is the remainder. Okay. Now once you have the remainder, compare the coefficients. Okay. Remainder is nothing but x plus a that is given. So x term has coefficient of 1 on the RHS side. Okay. And on the LHS side, minus 9 plus 2k. So equate them basically. Okay. From this, you get the k value, which is 5. Okay. And you substitute it in the uh, this one 10 minus 8k plus k square equal to a. So you get the a value. A is minus 5. So k is 5, a is minus 5. This is the value. So these kind of problems also can come. So this is how we will be solving these problems. Okay. Yeah, that's it. So we have finished the third chapter, that is polynomials from the Telangana Maths book, 10th class Maths book. Uh, these are really fundamentals and basics. And actually, in the Telangana Maths book, there are more chapters for polynomials, that is quadratic equations, linear inequalities also there. So this is basic actually. This is the basic. And from here, next we will do IOQM polynomial. We'll solve some problems, some different types of problems which can come in polynomials or maybe equations also. Okay, we consider them as same. So I will pick up all those IOQM questions and we'll solve the different problems there. So that is to go to next level. That will be helpful for your IOQM practice as well as your entrance, any entrance competitive exam, engineering or any competitive exam practice. Okay, thank you.